Okay. So the last time we have learned how could we deal with the equation, right? So and this time I need to give you another example. I need to give you another equation, and we can do it together. We can work out together this equation, right? But let me remind you what we have learned. We have learned it before. If we have, multiplying, we need to turn it into addition. And if you have addition, we need to turn it into multiplying. And if you have, dividing, we need to turn it into subtraction. And remember, every single time you've realized that we get a power, we need to kick it out. So to make it, as it sounds like coefficient, right?
Mm-hmm.
You get it?
Yes.
Is this one clear for you?
Yes, Mr.
Okay. So the point is, what if we have something? It sounds like we have, for example, we have logarithm on the. I'm talking about the left hand side. For example, we get 12x minus 7. On the other side, we got log. For example, 3x plus 10. I think you've realized that we don't have base, right? So
Yes.
every single time you've realized that we don't have base, remember there's a base is 10. But when the base is 10, we don't always write it. So it sounds like familiar for us. But I need you to realize that we don't have a base, but I think you get it by your own that the base is always 10. But the point is, I think that the basis sounds like the same in the left-hand side or right-hand side, right? Which makes sense. This one's pretty simple. And what I want to do is just to try to equilibrate between the left-hand side and right-hand side. And it sounds like a really simple equation, right? Which makes sense. I need to equilibrate between this part and this part. Did you get it?
Yes.
So you could write just like 12x minus 7, which equals to 3x plus 10, right? And this one sounds like a pretty simple equation. And what I want to do is just try to combine, the variables on the same side. We get the same variable x and x. And which makes sense, I need to move the smaller to the greater. So I need to get rid of 3x because this one sounds like the smaller, right? Which makes sense. I need to subtract 3x from both sides, the left-hand side and right-hand side. And remember, whenever something to the left-hand side, you have to do the same thing to the right-hand side because we are trying to keep it in balance, right? Which makes sense. This one's being canceled. So 12 minus 3x, which is going to be 9x minus 7 equals to 10, right?
Okay.
And then I need to add up 7. And
so we cancel it with the smallest number in the equation?
Yeah, sure.
Okay. And then the same thing for the other one, 7, 7?
Yeah,
and
so
then
it's 9x equals to 17, right? And then I need to divide by 9, and I need to divide by 9. So x equals to 17 over 9. Did you get it?
Okay.
And just
why not? We're not gonna write its decimal form?
No, yeah, I don't know, but just keep it. It sounds like the same. Like the fractional form. It sounds like, more better. But anyway, both of them are really the same. But
Okay.
I tend to write it in a fractional form. For me, it sounds like much more better, as I told you. So let me try to go a little bit further to something else. This one sounds like the last example that we have learned and we have discussed it together. So the point is, this time I need to make just a little discussion to find out how could we do it together. So the point is, even if we have logarithm and here we have x to, the basis 2, on the other side we get logarithm x minus 2, we get the same base, right, which equals to 3. So this one, I'm talking about the left-hand side because I really care about the left-hand side, not to the right-hand side. So basically, we get the same base. I think you have noticed, right?
Yes.
And this one sounds like it's kind of addition, right? So how could we do it?
Addition is going to be multiplication, so it's going to be, are we going to take the 3 out?
I need to write x, right?
Log 2x
And x has been
by
multiplied with
x
x
minus
minus
2.
2,
X
right?
times x minus 2, yes. Is
Yeah,
equals
which
to
equals to
3.
right?
Mm-hmm.
And then I need to distribute it firstly. I need to get the expansion of it, which
So
makes
x
sense. If we
times x.
x times x, which is supposed to be x squared, right? And x
X
minus 2, this
squared.
one looks like, minus 2x, which equals to 3. Right now, it's time for turning it from being written in logarithm equation into exponential equation because it helps us to get the answer, right?
Mm-hmm. So it's gonna be
2 to the power of
2 to the power of 3.
which equals to x squared minus right?
2 to the power of 3 is equals to x squared minus 2x. So 2 to the power of 3 is gonna be 8. So it's gonna be
Yeah.
8 is equals to x squared minus 2x. And then it's gonna be x squared minus 2x minus 8 is equals to 0. And then we're gonna separate them. So it's gonna be x minus 8 and x.
The sign of the last term, it sounds like negative, right? What is the two factors, if we try to multiply them,
It's gonna be
give us
negative and
8.
positive.
We have 1 and 8, and we have 2 and 4, right?
Wait,
I'm looking for two of them, the
is there
difference
what?
between,
Oh, you mean
yeah,
these are like the factors of 8?
yeah, these are the factors of 8, exactly.
Oh, okay.
But you know,
So it's gonna be صح wait, it's gonna be x minus 2, x plus 4.
no, wait, hold on, you have made a mistake. You have made a
Or
silly
the
mistake.
opposite. Oh, the opposite,
X and
right?
X,
X minus
4 and
4,
2, right?
x plus 2.
Do you know why did I back up 2 and 4? Because the difference between them, it's going to be the same of the middle. The middle sounds like 2x, right? Which makes sense. If you try to subtract 4 minus 2, it's going to be the same, which makes sense. It's going to be 4 and 2. And basically, I told you the last time, the greatest one of them takes the same sign of the middle, which makes sense. This one's going to be negative, and this one's going to
So
be
it's gonna
positive.
be okay, so it's gonna be x minus 4, x plus 2 equals to 0. And then it's gonna be x minus 4 equals to 0. And x plus 1 is equals to 0. So it's gonna be x equals to 4. And then x is equals to negative 1.
Yeah, right. Did you get it?
No, wait, negative 2, sorry.
Did you get it?
Yes.
Okay. So I think it's really, really, it's really easy, right?
Yes, it is.
Okay. So let me try to go, a little bit farther to something else. But I need you to remember that every single time, as I told you, if we have something like this one, we need to remember that, the rules of logarithm, okay? Okay, what if you have logarithm, for example, if you have logarithm 5x, which equals to logarithm of x plus 4 plus logarithm 3. How can I do it?
Is this the same as the last question, or is it different?
Yeah, the same as the last question, but we get a problem. The problem, it's all about the right-hand side, not the left-hand side. But why? Because the right-hand side, we get something. It sounds like we get an addition, right? Which makes sense. I reminded you that if you have addition, we need to turn it into multiplying, right? Which makes sense that we get the same base. The base right over there sounds like 10 and 10, right? And I told you that we don't write it, which is the base is 10, we don't write it, which makes sense. I
Mr.
need
Why
to
does it sound like 10 and 10?
because I told you, I mean, at the beginning when they were, I mean, when they invented to only the base 10. So
Also, it's like a fixed number?
yeah, every single
Okay.
time you realize that we don't have a base, so the base is always 10. Okay. So what I want to do is just try to keep the left hand side. I need to keep it. I don't have to change it. But the point is right over there. I'm talking about the right hand side. We got something that sounds like addition, right?
Yes.
So which makes sense. I need to turn it into multiplying, right? Let me write it. 3, and this one's going to be multiplied by x plus 4, right?
Equal to log a x. Yes.
So it makes sense. I turn it up from being written into addition into multiplying, right? And then I need to distribute it. So here we have logarithm, which equals to log. And let me try to distribute it. So it's going to be 3x plus 12, right? And let me cancel. We got, a couple logarithms in both sides, which makes sense. I need to cancel them out. So this one is this one. So, and this one sounds like a pretty simple equation, right? You could solve it.
Okay, and why did we cancel the logs?
When we have the same logarithms, they have been written in both sides. We get the same, base, the same logarithm. We need to cancel them out.
Okay, so what do I do now?
So 5x, which equals to
Equals to 3x plus 12.
3x plus 12, right?
And then it's gonna be 3x plus 12 plus 5x is equals to 0.
No, wait, hold on. I need to subtract
Ah,
from both sides, right?
okay, wait. 5x plus 3x plus 12. So -3, Mr. Oh, you changed the sign. Okay, right.
Yeah, I changed the sign because I need to get rid of 3x.
So we cancel 3 and 3, and then we do 5 minus 3.
Yeah, it's going to be 2x, which equals to 12.
So 2x is equals to 12, and then 2x by 2x, and then 12 by 2x.
So what x stands for?
X is equals to 14.
You mean 12 divided 2? What is 12 divided 2?
Ah, wait, I added them. So it's 12 divided by 2. So it's 6.
Did you get it?
So x is 6. Yes, I got it.
Is this one clear for you?
It's clear for me.